Hello everyone, with Mr. Articosa, the face of mathematics. We are continuing from the last video on factorization theorem. I defined the theorem, so now we are going to question type, the limit. So as I'm about to share with you the knowledge that I have, because sharing is caring and knowledge is sharing. Recall the factorization theorem defined by a to the power n minus b to the power n, which is given by a minus b multiplied by a to the power n minus 1 plus a to the power n minus 2b plus a to the power n minus 3b squared plus until b to the power n minus 1. So for a squared minus b squared is the difference of two squares, where our n is 2. And also recall that your x can be written as the square root of x squared, or the cube root of x all cube, or the fourth root of x all to the power 4. A cube minus b cube is given by this a minus b multiplied by a squared plus ab plus b squared. And also a cube plus b cube is given by this a plus b multiplied by a squared minus ab plus b squared. Lastly, a to the power 4 minus b to the power 4 is given by a minus b multiplied by a plus b multiplied by a squared plus b squared. So this is most important property that we're going to apply when we're dealing with limit. So let's begin. Suppose we ask to solve a limit as x approaches 1 of x minus 1 all over the square root of x minus 1. What you need to do first is to express x as a square root. Remember, I told you that x can be written as square root of x all squared. So which means what I'm going to do here, I'm going to say the square root of x all squared. It will take me back to x minus 1 squared. We take it back to 1. Divide by the square root of x minus 1. And also don't forget the limit. If we proceed, this will follow factorization theorem. In this case, your a is square root of x and your b is 1. And we're going to apply this one that you see here. So this is the same as the limit x approaches 1. I have square root of x minus 1, square root of x plus 1. As you know, a squared minus b squared, it's a minus b multiplied by a plus b. So this is still divided by the square root of x minus 1. You can see this is common. Then I'm left with the limit as x approaches 1 of the square root of x plus 1. So if I substitute 1 here, I'm getting the square root of 1 plus 1, whereby I get 1 plus 1, which is 2. That's it. Now let's verify the law. This one. I want to prove that this is true. So I have x to the 1 minus 1. Remember the limit. X half minus 1. What did I say? M. What is your m? It's 1. 1. And what is your n? It's 1 over 2. And this becomes 1 multiplied by 2 over 1, which is 2. Indeed, this is correct. It is always important to check the common factor between the numerator and the denominator, especially when dealing with a limit of factorization type. If you can check from the problem that we just solved now, the square root of x minus 1, which is the denominator, is the factor for the numerator x minus 1, since we know that x can be written as the square root of x squared. But there are also other type of limits where you find that there is no factor between the numerator and the denominator. So we'll have to find the factor of both the numerator and the denominator. The limit as x approaches 1 of the cube root of x minus 1 over the fourth root of x minus 1. If you can check between the numerator and denominator, they are not factor of each other. So we must find the factor of both the numerator and the denominator. So we need to first write this expression in exponential form. So this is the limit as x approaches 1. I will change the cube root of x to the power 1 over 3 minus 1. And I also change the fourth root of x to be x to the power 1 over 4. Then I subtract that one. So between the two, I'll be looking for the factor of x to the power 1 over 3 and x to the power 1 over 4, which is x to the power 1 over 12. How did we find 1 over 12? I said 1 over 3 multiplied by 1 over 4, meaning I can write this limit as the limit as x approaches 1. Where I see x to the power 1 over 3, I'll replace by x to the power 1 over 12 raised to the power 4. If I multiply 4 with 1 over 12, I'll get back to 1 over 3. Then minus 1 to the power 4. Divide by. I'll replace x to the power 1 over 4 also by x to the power 1 over 12 raised to the power 3. Minus 1 to the power 3. So now I can apply my factorization theorem. If I can check on both the numerator and the denominator, my factor is given by x to the power 1 over 12 minus 1. X to the power 1 over 12 is A, and 1 is your B. And I'll start for the power 4. So it means I'm applying this formula. Where I see A, I replace by x to the power 1 over 12. Where I see B, I replace by 1. So let's just simplify this expression. So this is the limit as x approaches 1. X to the power 1 over 12 minus 1. X to the power 1 over 12 plus 1. And x to the power 1 over 6 plus 1. Why 1 over 6? Remember, it's saying a squared plus b squared. And a square of x to the power 1 over 12, it's x to the power 1 over 6. That one you'll understand. Divide by. This I'm going to use for the power of 3. You can see the formula. X to the power 1 over 12 minus 1. Then x to the power 1 over 6 plus x to the power 1 over 12 plus 1. So I just replaced this here, as you can see. So this is the result in the denominator. So you see that this is common. So I'm left with the limit as x approaches 1. So here I have x to the power 1 over 12 plus 1, x to the power 1 over 6 plus 1, all divided by x to the power 1 over 6 plus x to the power 1 over 12 plus 1. So now I can substitute. I'm having 1 to the power 1 over 12 plus 1, 1 to the power 1 over 6 plus 1, divided by 1 to the power 1 over 6 plus 1 to the power 1 over 12 plus 1. So what I'm having here is 1 plus 1 multiplied by 1 plus 1 all over 1 plus 1 plus 1. So I'm having 2 times 2 over 3. So the answer is 4 over 3. To verify using the formula that I gave you, I said the limit as x approaches 1 of x to the power 1 over 3 minus 1 all over x to the power 1 over 4 minus 1, it will be given by 1 over 3 divided by 1 over 4. If you can check very much carefully, I am having 1 over 3 times 4 over 1. So indeed we still get 4 over 3. So that's it for factorization theorem. It's about finding the factor for both the numerator and denominator. Thank you. Keep on subscribing, supporting. You're welcome.